Right, now that we've proved that opposite sides in a parallelogram and opposite angles in a parallelogram are congruent, we want to prove one more property, that the diagonals in parallelogram bisect each other. So basically what I have here, the diagonals are drawn, these alternate interior angles are congruent, and the opposite sides are congruent. So that gives me two congruent triangles. Triangle BCO is congruent to triangle DAO. So by that property, the sides here, OD and OB, are corresponding sides, so they must be congruent. So I can say side OB is congruent to side OD by CPCTC. Well, I also didn't state why these two triangles were congruent. It's angle, side, angle in the one triangle is congruent to angle, side, angle in the other. So let's say by angle, side, angle. All right, so now I know that the diagonal bisects this diagonal. And now I'm going to go ahead and show that these two line segments are the same as well. And that's also by CPCTC. OA is the third side of this triangle, and OC is the third side of this triangle. So OA is congruent to OC by CPCTC. So I know that those two sides are, those two segments are congruent to each other. So therefore, the two diagonals bisect each other. All right, so this gives rise to a whole bunch of properties of parallelograms and in general of other quadrilaterals. So let's go ahead and walk through our favorite quadrilaterals, the ones that we've named, and see if we can name any properties. So the definition of a trapezoid is just a quadrilateral with at least one pair of parallel sides. So BC and AD are parallel. So one thing that I can say for sure is that consecutive angles between the parallel sides, I spelled that wrong, Parallel, between parallel sides are supplementary. All right, and that could be seen by if you extended this and saw the alternate interior angles here. These two angles are congruent. These two angles are supplementary, so therefore this angle, which is the same as this angle here, these two angles have to add up to 180 degrees. So these two add up to 180, and also these two add up to 180. Now in an isosceles trapezoid, which is defined by a trapezoid with a pair of congruent base angles, then, well, we know for sure that the base angles are congruent, but also the opposite base angles are congruent as well. Because if these two add up to 180 degrees and these two add up to 180 degrees, since these are the same, these have to be the same. So we can say first that each pair of base angles are congruent. All right, you can also say that these two sides have to be congruent as well. So we can say that a pair, at least, of opposite sides are congruent. And lastly, that if a trapezoid has congruent diagonals, then it has to be isosceles. So if I had any old trapezoid and I wasn't sure if it was isosceles or not, if you know that this diagonal here is the same as this diagonal here, then you would have congruent triangles, which would give you that the corresponding parts would be congruent as well. So if a trapezoid has congruent diagonals, it is isosceles. Let's move on to parallelograms. Now we just did a whole bunch of explorations on parallelograms. So what we know is, just given the definition that the opposite sides are parallel, you know that the opposite sides are congruent. You also know that the opposite angles are congruent. And we also know that the diagonals bisect each other. And this is an if and only if statement. Namely, if you have a quadrilateral that have diagonals which bisect each other, then automatically you've got a parallelogram. All right, now discuss rectangles. A rectangle is a parallelogram with one right angle. Okay, so what we know is that a rectangle is a parallelogram. So all properties of parallelograms hold here. Also, we know that the opposite angles in a parallelogram are congruent, and adjacent angles are supplementary. So these two add up to 180 degrees. So if this one's 90, this one has to be 90 as well. And therefore, this opposite angle is 90 degrees. So we know that if we say it's a parallelogram with one right angle, you get for free that all angles are 90 degrees. All right, and because it's a rectangle, these two diagonals have to be the same length. So the diagonals not only bisect each other, but they're congruent. So the diagonals are congruent and bisect each other. All right, and then the last thing is that these properties actually can define a rectangle. So if you have any quadrilateral where the diagonals are congruent and bisect each other, it's a rectangle. Or if you have any quadrilateral where you have all 90-degree angles, has to be a rectangle. Let's now discuss kites. A kite, by definition, is a quadrilateral with two adjacent sides congruent, and then the other two adjacent sides have to be congruent as well. So here's the kite that I think we're familiar with. These two sides are the same, and the two other adjacent sides. But kites can also be concave. All right, so one property is that the lines containing the diagonals are perpendicular to each other. All right, and here's how I know that. Imagine this, the diagonal here made from D to B. Because these two adjacent sides are congruent, and also these two adjacent sides are congruent. Looks like I have a little isosceles triangle on one side of my line segment and isosceles triangle on the other side of my line segment, and connect those two vertices. And we saw before that that's how you construct the perpendicular bisector of a segment. All right, so the two diagonals are perpendicular to each other, and in fact, one of the diagonals is the perpendicular bisector of the other diagonal. So in fact, one diagonal, in this case it's AC, perpendicularly bisects DB. That means that this length and this length are the same and they meet in a right angle. So AC is the perpendicular bisector of the other. In this case, that was DB. Okay. And see what this looks like in a concave kite, that this diagonal AC, we actually have to extend it out a little further in order for it to intersect with the diagonal DB. In the concave kite, one of the diagonals actually does not lie in the interior of our shape, so it makes it look a little bit strange. Okay, and the last property is that this actually defines what a kite is. If you have any quadrilateral where the diagonals are perpendicular to each other, and in fact that one diagonal is the perpendicular bisector of the other diagonal, then it has to be a kite. All right, let's now move on to rhombuses or rhombi. So rhombi are kites, and they're a special type of kite, special type of rectangle or parallelogram, and a special type of trapezoid. So they inherit all the properties of kites and parallelograms. So all parallelogram and kite properties hold here. And in fact, a quadrilateral is a rhombus if and only if all four sides are congruent. So again, it could have been defined by saying it's a parallelogram with two adjacent sides congruent, but in a parallelogram, the opposite sides are congruent. So saying two adjacent sides are congruent, you might as well, that implies that all sides are congruent. So all sides congruent. All right. And another property is that the diagonals of a rhombus are perpendicular to and bisect each other. So in a kite, we had that one of the diagonals is the perpendicular bisector to the other, but in a rhombus, they're perpendicular bisectors of each other because they're all the same sides. So the diagonals are perpendicular bisectors of each other. Okay, so that means that these two lengths are the same and these two lengths are the same. So now what you see if you draw on those diagonals is you have a whole bunch of triangles that are congruent to each other. So because of that, now I know a whole bunch of angles that are congruent to each other as well. So this triangle AB, if I call that O, ABO and ADO, these are congruent. So these angles here have to be congruent. So that means that the diagonal chops the base angle into two equal parts. So the diagonals bisect the vertex angles. Okay. All right, and last but not least, square. A square is a special type of rhombus, which is a special type of kite, and it's also a special type of rectangle. It's also a special type of parallelogram. So I can say a square inherits all properties of a rhombus and of a kite and of a rectangle and a parallelogram